Okay, let's do a quick recap of chapter 6.3. The first thing we had was properties of definite integrals, and I'm not going to sort of rehash all that here. If you're using the same book, and go to page 293, there's a full table. I believe in one of the earlier videos, I may have pasted that table, and you might go back and take a quick look at that. Some things that we did learn how to calculate. First of all, an average or mean value. Here's what we said is we said, well, if we take the area of our function between a and b, so we calculate the total area of that function, and we divide by the width of the function, or the interval, that'll tell us the average value of the function. Can be a useful thing to know is what's my average. Mean value theorem for definite integrals is basically the same as the mean value theorem for other things. Again, we have to have a continuous function on our interval, otherwise this doesn't apply. But there will be some c in the interval, so a less or equal to c less or equal to b, such that f of c is equal to the average value of the function. So find that average value, and then there must be some point in that interval where the function equals the average value. In other words, you can't get from one side to the other without going through the middle, to put it non-mathematically. All right, the concept of an antiderivative. One of the things that we talked about is that the derivative of the integral from a to x of f of t dt is just the function evaluated at x. Since integral is an antiderivative, obviously, or you may remember that the whole point of inverse functions is that they cancel each other out. And we came up with this idea that if we define f of x, capital F, uppercase F, that the integral from a to x of f of t dt can be calculated by taking the antiderivative at x minus the antiderivative at a, our lower boundary. And so this is going to come in really useful in the next section, where we're going to actually give this idea right here. We're going to give it a name. And quick heads up, we are going to call it the fundamental theorem of calculus, because it is really, really basic to the idea of calculus. If you can find the antiderivative of that function, you can calculate this integral without going through all of the hoops and process. Okay, that was chapter 6.3 in our book. Hope you learned something, and thanks for watching.